All right, boys and girls, welcome back to the drive-thru. Sponsored you by the deli. Hungry? Stop by the deli. Make yourself a peanut butter and jelly sandwich on 7-grain wheat with extra peanut butter. Okay, this is 10-4, number 78. The problem reads, consider the two curves y equals x squared and y equals x to the 1/3. Find the unit vectors tangent to each curve at their points of intersection. Then find the angle between the curves at their point of intersection. Okay, I've sketched a graph here, and I've listed the blue curve as y equals x to the 1/3. The black curve is y equals x squared. Y1 prime is 2x. Y2 prime is 1/3 x to the negative 2/3, which is 1/3 radical cube root of x squared. Okay, so why do we have the derivatives? Because we need to find the slope of the tangent lines. We need to find the tangent lines and turn them into unit vectors. So we know that this point right here is 1, 1. If you think about it, these two curves will intersect at 1, 1 and at 0, 0. So I've kind of made an organized list here, okay? At 0, 0, let's see, how did I write this? M1 equals 0. So when I put in a 0 here, I get 0. M2 is, well look, if I put in a 0 here, you're going to get a 0 under a radical in a denominator, so that's going to be undefined. Okay, so let's just get that one done. At the point 0, 0, the unit tangent vectors could be, well, if the slope is 0, that's a horizontal line. So let's see, that could be represented in a unit tangent vector by 1, 0. And this slope would be 0, 1. And notice their dot product is 0. And you already knew that the angle between them at point 0 would be 90 degrees, okay? At 1, 1, the slope of the first equation is 2. The slope of the second equation is 1/3, okay? So, now, we need, first let's just create a vector whose slope is 2. And that's going to be 1, 2. Remember, rise over run. Okay? This one, we could call it the vector 3, 1. Rise over run. Well, that doesn't answer the question for us. They want a unit vector. The magnitude of this one is 5. The magnitude of this one is 10. Okay? So we can say that it'll be 1. No, sorry, radical 5. Shoot, sorry. Radical 5 and radical 10. You're used to that if you're in this class. Okay, and I'm glad you asked this one. So that's the answer to the question. Find a unit vector tangent at the point of intersection for both. Now, if we want to find the angle between the curves, we need to find the angle at that point in between the tangent vectors. So we're just going to do the dot product. But why? Don't use the unit vector when you do the dot product. Let's call this u, and let's call that v, and just do u dot v. It's so much easier. So u dot v is equal to 1 times 3, which is 3, plus 2 times 1, which is 2. Magnitude of u is radical 5. Magnitude of v is radical 10. So that's u dot v over magnitude of u times magnitude of v. All right, so we know that cosine of theta is equal to 5 over radical 50, which is 5 over 5 rad 2, radical 2 over 2. So cosine theta is equal to radical 2 over 2 when theta equals 45 degrees. So amazing. Those two curves intersect. This angle here is 45 degrees, and that angle there, amazingly, is 90 degrees. Boom!